Hybridisation.com.
Okay, students, now we are going to start with the very important chapter of second year or 12th class, and that is very difficult to understanding also. So for that, I will be explaining clearly so that you can understand it nicely. Okay, so the what is the topic? Structure. What is the topic? Structure of coordinate complexes. Okay, coordinate complexes. So this is the topic which most of the students are not knowing, because of which I have to do this video. Understood? Anyhow, if you got any problem in this previous to this also, there are lot of topic. So if you want me to cover that, then I will cover them also. Okay, but that you should mention in the comment section whether topics before this, like isomerism is there, like naming is there. Okay, so I will be making upon videos as per your request made in the comment section. The more nice you respond to my videos, the more view I get, more watch time I get, more people are encouraging me with their good reviews, more likes I get, then I will be doing according to your own requirement. Okay, so my response is just a mirror reflection of your response. How you can respond? You can review by writing a good comments. You can like my videos. You can watch more and more time. Okay, so because of which I will also be happy and you will get your information. Understood? Only thing I expect from you is likes, shares, subscriptions, and good comments. Okay, everything is free. Understood? So let's start with the today's topic, structure of coordinate complexes. Okay, so structure of coordinate complex will completely depends on the coordination number. What is number? Coordination number. So first you should understand coordination number. Okay, so coordination number is simply number of lone pair. Number of lone pair gained by a metal. Okay, this is called as a coordination number. So depending on the coordination number, the entire structure will be determined. Okay, so as of now we got some coordination numbers. Okay, so I'm going to write the coordination number and possible feasible structure of that. Okay, so first coordination number can be 2. Okay, what can be the first coordination number? Coordination number can be 2. That time the structure will be, sorry, hybridization will be Sp hybridization. What will be the hybridization? Sp hybridization. Then the shape is going to be linear. Okay, I am giving you only possible things. It is not that I will bring some impossible things which never asked and which nowhere available in NCERT, nowhere available in syllabus. It is not my way of teaching. I will teach you within the syllabus. Only thing is I will make it easy to understand and better scoring. Okay, so my teaching will be mostly as per the exam pattern. Okay, and making it easy, not making something like hype. I'm not going to create some hype so that you should feel that I'm going to teach very big things. Okay, so if big things I'm teaching and you are not able to understand, you are not able to score, then what is the use? Okay, so next, coordination number 4. What is the next possibility? Coordination number 4. Okay, so coordination number 4, then there are two possibilities. Sp3 hybridization also possible, dsp2 hybridization also possible. These are the two types of hybridization possible. Okay, if the hybridization is sp3, then the complex coordinate complex structure is going to be tetrahedral. What hedral? Tetrahedral. Okay, so this is the tetrahedral when coordination number is 4 and hybridization is sp3. Okay, now coming to the next part, when coordination number is 4 but hybridization is dsp2, what, how you will find out this hybridization? I'm going to cover it with one example each. Okay, because these are the things which you are going to face in the examination. Understood? So in the dsp2, that time structure will be square planar. What will be the structure? Structure is going to be square planar. Okay, so how to identify dsp2 or sp3, leave it to me, that I will explain you for the time being. Understood? Next, coming to the coordination number 5. What is the possible coordination number? 5. Okay, so that time only hybridization will be sp3d or dsp3. Okay, otherwise dsp3 also no problem. Understood? With this example I will tell you, don't worry, that time it will be tbp. Okay, what is tbp? Triangular bipyramidal. The structure is going to be triangular bipyramidal when coordination number is 5, the hybridization is only one chance, not like here. Okay, so if coordination number 5 is there, then it is going to be dsp3 hybridization. The main thing you have to remember, you should never skip, is about the coordination number 6. What is the next topic? Coordination number 6. Okay, so coordination number 6 means, if the coordination number is 6, then hybridization may be D2sp3 or sp3d2. Hybridization can be what? D2sp3 and dsp3. Okay, sp3d2 or d2sp3. sp3d2 or d2sp3, both are possible. Okay, so try to give a good comments, because this chapter is very important. Until unless you don't uh, clearly explain through the video lecture, it is very difficult chapter to understand from reading the books. Okay, and as I know the problems faced by the students while reading the books, that's why I am making this video, and a lot of requests came for this chapter only. Okay, so this is D2sp3. Even though the structure is same, what is that? Octahedral. Okay, octahedral. Otherwise, it is also called as square bipyramidal. What it is called as? Square bipyramidal. Okay, octahedral also called as what? Square bipyramidal. Up to here, you just, I am giving you an intro. Don't think that no doubt should come after the class. Okay, so everything will be cleared about the structures. Is it understood, students? Okay, ready to go for the examples? Okay. Okay, students, now we are going to start with the one by one examples. Okay, one by one examples we are going to start. Ready? So AG47 KR 4D10 5S1. First example for the SP, hybridization and linear configuration. Okay, sorry, linear structure. What is the structure? Structure is should be the linear. Structure should be linear, and hybridization must be sp3. So hybridization must be sp hybridization, and structure must be linear. Okay, so silver atomic number, the example for this is AgNH3 twice positive. Okay, and atomic number is 47, and it is krypton 4d10 5s1. This is the electronic configuration. Now, according to the oxidation number, Ag plus 2 into NH3 is equal to how much charge? Plus 1. And silver, as ammonia is a neutral complex. Ammonia is what complex? Neutral complex. Silver oxidation number is going to be plus 1. Silver oxidation number is going to be how much? Plus 1. So there will be one electron lost. Okay. So the configuration of the Ag positive. is going to be krypton, 4d10 and 5s 0 and 5p something 0. Okay, so as the electrons in the 4d are completely filled, subshells in the orbitals in the 4d is completely filled, there is no place at all. Okay, so because of which what it will do, it will utilize how many ligands are approaching, two ligands. Okay, for two ammonia are approaching, and here we are discussing about the coordinate covalent bond. Therefore we should count the number of empty orbital which are required for coordinate covalent bond. Here coordination number is 2, so we should count two empty orbital. Okay, so the empty orbital starts from here and coordination number is 2, 1 comma 2. So hybridization is going to be sp hybridization. Okay, sp hybridization, as you can see there is no unpaired electron. Okay, so because of it, it is diamagnetic. Which magnetic? Diamagnetic. Okay, and the shape what it is going to be, it is going to be linear shape. Is it understood? First example, any doubt about this? Okay, like this only we are going to solve it one by one. Okay. Okay, now we have entered into the coordination number 4. Okay, in the end I will give you some additional information required for advanced examinations. Okay, so these whatever I am teaching now, they are only for the very essential. Additionally, if you are enthusiastic and if you wanted to leave nothing unattended, I will give you like sp3, sp2. Okay, so sp2 I have left. So some typical examples, some rarely asked exams, so example also I will be going to cover. Okay, now in the coordination number 4, as I told you, there are two types of configuration structures are possible, because two types of hybridization is possible. So let us take one by one examples, and for easiness I will give you the comparison also. Okay, first let us start with the NiCl4 2 minus. Okay, so I think all of you are aware about the atomic number of the nickel. Okay, so what is the atomic number of nickel? It is 2828. 28. So helium, neon, argon. Okay, argon will be 18. Then 4s2 and 20, 3d8. This is the configuration of the nickel. Okay, but here if you find out the oxidation number of nickel is going to be +2. Oxidation number of nickel is going to be how much? +2. Why? Because nickel is nickel plus 4 into -1 is equal to -2. So you will get +2. Okay, so I have to remove the 2 electrons to form nickel +2. Then it is going to be argon and 3d8. This electron will be out. Okay, so that electron being out, here 1 2 3 4 5 6 7 8. Okay, and 4s is 0 and 4p also 0. Okay, so as I told you, in the coordinate covalent bond we have to count the empty number of orbital required as per the coordination number. Here coordination number is how much? 4. How 4? Because 4 chlorines are there. Okay, so 4 chlorines, and hybridization will be sp3 hybridization. What will be the hybridization? sp3 hybridization. Here two unpaired electrons are there. What are there? Two unpaired electrons are there. Hence, it is going to be paramagnetic. Which magnetic? Paramagnetic. Okay. So sp3 with, so this is going to be the paramagnetic. Because of this entire explanation, you will be able to find out the everything about the compound. Okay, so like paramagnetic, how you are coming to know? Because of the unpaired electron, and the structure is going to be in the central. It is going to be nickel +2, and it all 6 chlorine minus. How many chlorine minus? 6 chlorine minus will be projected 6 chlorine minus will be projected from 4 coordinate covalent bonds. Okay, so when I attach them together, okay, when I attach them together, I am going to get a beautiful tetrahedron. Okay, is it clear now? This is the coordinate covalent bond. And how they are projected? They are projected in by staying at the corner of a regular tetrahedron. Okay, so this is the structure and magnetic nature of the nickel tetrachloride. Now, are you getting some idea about the how to find out the structures? Okay, now let us take one more beautiful example. I am going to take, that is NiCO4. Okay, what is that? NiCO4, but charge is 0. Okay, what it is? Charge is going to be 0. NiCO4 charge is 0. Okay, now again same thing we will repeat. Nickel atomic number 28. So helium, neon, argon. Okay, argon is 18 and 4s 0 and 4d 10. Okay, so it is 4s2, sorry, 4s2 20 and it will be 8. Okay, so this is the configuration. Okay, and fortunately, fortunately, there is no electron need to be removed. Why? Because oxidation number is how much? 0. Okay, so once oxidation number is 0, what we will do? We will do directly. Okay, so here I am writing oxidation number is equal to 0. Okay, once there was a entrance question in homoleptic, in homoleptic homoleptic carbonyls. Okay, oxidation number is always how much? 0. Okay, what is the question? In homoleptic carbonyls. Okay, which carbonyls? In homoleptic carbonyls, oxidation number is how much? 0. Okay, so Ar is, that's why I am not removing any electron. Always you remember, this is a very important direct objective. Okay, it is very important, but direct objective. Okay, so oxidation number is going to be how much? 0. Okay, now let us see about the argon 48 4s0. So, but it have to provide how many unpaired how many empty orbital? 4 empty orbital is to be provided. For that, what we will do? We will break the half bow rule. Okay, half bow rule, that is actually after filling up this only we should fill up. Okay, so pairing against Hund's rule. Okay, what it is called as pairing against Hund's rule. Okay, now the electronic configuration will be written as per pairing against the Hund's rule. Okay, what is the pairing against Hund's rule? Means without filling up this electron will come back here. Okay, when it happens, when it due to strong field ligand, that is CO. Okay, carbon monoxide is a strong field ligand. What is strong field ligand? How you will identify? Everything will be explained in the crystal field theory. But for the time being, you should remember it as CO is a strong field ligand. Whenever there is a strong field ligand like it is present, then if possible, what we will do? We will pair this electron where they will come back. Okay, their field is so much strong that this electron will come back and pair. Okay, so because of this there is a lot of changes. Okay, what are the lot of changes? I am going to explain here. Okay, so argon is going to be same and 4d8 was there, now it is going to be 4d10. What it is going to be? 4d10 and it is 4s0. Okay, sorry, this is 3D. Very bad. Okay, 3D 10, 4S0 and 4P0. Okay, so This DO subshell will contain how many orbital? It will contain 5 orbital. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now 4s0 and 4p0. Okay, 4s0 and 4p0. The hybridization is going to be, what is hybridization is going to be? Sp3 like NaCl4. Okay, NaCl4 was 2 negative, but NaCO4 is 0. That is one change. Structural property is same, but when you observe there and here, what is the difference? There it was 2 electron unpaired, but here no unpaired. Okay, no unpaired. So because of the no unpaired, what will be the structure? What will be the magnetic nature? It is going to be diamagnetic. Okay, diamagnetic. Now is it clearly visible to everybody? Okay, good. Okay, so this is about the NaCO40. Second example of the coordination number 4 I have explained. I have explained the second example of the coordination number 4. I am going to cover one more beautiful example. Wherever it is required, wherever it is typical, wherever there is a chance of asking the questions in the examination, I myself know. As I am teaching since years, I know the difficulties faced by the students. According to that, I made my lecture on. Okay, so let us go for the third example of the coordination number 4. Okay. Okay, we are into the next example of the coordination number 4. If I am giving you 3 examples for same coordination number, you should understand the importance. Okay, if I am explaining something again and again, it means that it is important. You should understand. Okay, so NaCN4 2 minus. Now again same configuration. What is the atomic number? 28. Helium, neon, argon. Okay, and 4s will be 0. Sorry, 4s2 20 and 3d 8. Okay, now let us find out the oxidation number. Here again nickel oxidation number is +2. So once oxidation number is +2, what we have to do? We have to eliminate 2 electrons. Okay, so the nickel +2 configuration is going to be AR, and 3D 8 is going to be same, but 4s is going to be 0. Okay, and apart from that, what will be there? 4p0 will be there. Okay, so in the previous example I have not drawn the structure. Okay, why? Because it is structure is everybody know that. Okay, so this is the 3d8 and it is 4s0 and it is 4p0. Okay, so 4 empty orbitals are required. Again what we have to write? Pairing against Hund's rule. Which rule? Hund's rule. Okay, then what happens? This electron will come over here. This is to be done due to also I will write. Okay, due to strong field ligand. Strong field ligand, what is that? Cn minus. What is that? Cn minus. Okay, now if this electron comes over here, argon. Okay, and 3d8 is going to be 8 only, and 4s0 is going to be 0 only, 4p0 is going to be 0 only. Okay, but there is a magic. What is that magic? I am going to explain here. So this, because of this pairing, there is empty orbital provided. Okay, now hybridization will start right from here itself. Okay, 3d8 4p0. Okay, because we require only 4 empty orbital, so hybridization is going to be dsp2 hybridization. What is the hybridization? dsp2 hybridization, and shape is going to be square planar. Shape is going to be what? Square planar. Okay, so this is what the structural. And what is the magnetic nature? Magnetic nature, it is diamagnetic. What magnetic? Diamagnetic. So we have studied three different examples. Okay, NaCl4, NaCN4, NaCO4. All of the three are different in some or other extent. Some things are hybridization is different, some things are magnetic nature is different. Now I am going to draw the structure for this because DSP2 we have not yet drawn. Okay, so this structure I am going to draw it. Listen carefully. So here nickel is +2 and it is associated with how many people? 4 Cn minus. How many Cn minus? 4 Cn minus. Okay. So when you join them, when you join them, what you will get? This is a square planar shape. Okay. So in the previous also, if you want, I will draw the diagram also. Okay. NaCl4, I think. Sorry, NaCO4. Okay, in NaCO4 they will be projected at the regular tetrahedron only. Where they are projected? They are projected at the regular tetrahedron only. The main thing, the difference over here is that this, so all the three. Okay, if you compare this NaCl4 2 minus NiCO4 and NiCN4. See how similar they are appearing, but there is something difference is there. Okay, so should I erase this? Okay, with your due permission, I am erasing this. Okay, so these two have same structure. What is the hybridization? Sp3. Okay, and these two they have same diamagnetic. Okay, is it understood? They both are same in the hybridization and structure. These two are same in the magnetic nature. Okay, so like that there is something similarity, something difference. That's why all the four examples I have taught you. Okay, next we are starting with the next example of coordination number 5. Okay, coordination number 5. What still last? Because in the last I am going to give you some valuable information. Okay, so coordination number 5. Okay, in coordination number 5, FeCO5. Okay, example is what? FeCO5. And here what we should write? Fe. Atomic number is 2626. Okay. Now electronic configuration will be argon 4s2 and 3d6. Okay. What is going to be 3d6? 3d6, 1s2, 3d6. Okay, and it is 4s2 and 4p is going to be 0. Okay, now we require 5 empty orbital and oxidation number is equal to 0. So for providing the 5 empty orbital, again this pairing against Hund's rule. Pairing against Hund's rule. Okay, when you will do, when you will not do. Okay, that you will come to know when you go through the spectrochemical series. Okay, so here if this comes here, if this comes here, these two orbital will be empty here like this. Okay, so ultimately what it will be, one empty orbital will be there, argon. Okay, 6 plus 2, that means 3d8. So what there will be, 1 2 3 4 5. So all 8 electrons will be accommodated like this, and 4s is going to be 0, 4p is also going to be 0. Okay, so are you able to understand now? Now this is DSP, sorry, DSP3 hybridization. DSP3 hybridization. Okay, so DSP3 hybridization, is it understood? Now can you expect the magnetic nature? It is diamagnetic. Okay, now structure I am going to write over here. Okay, so structure wise, Fe, Okay, this is the trigonal bipyramidal. What is the structure? Trigonal bipyramidal, TBP. Okay, trigonal bipyramidal. Do you understand now? Anything doubt about this? Okay. Next, we are going to start with the next example where coordination number is how much? 6. Okay, coordination number 6. Are you ready for that? Okay, coordination number 6. First example, CrH2O, or simply I will take CrCl6 3 minus. Okay, what is the first example? CrCl6 3 minus. Okay, so in this one, atomic number of chromium is 24 and helium, neon, argon. Okay, and exceptional configuration 4s1 and 3d5. Exceptional configuration is what? 4s2 3d5. Do you remember when you were in the 11th class atomic structure? This was studied with the utmost care. Okay, and it was taught to you clearly. So 3d5. Now here the oxidation number, if you calculate, it is going to be plus 3. What it is going to be? Plus 3. Okay, so for the plus 3 configuration, AR 3D is going to, one electron will be removed from here, then two electron will be removed from here. So 3D 3, 4s is going to be 0, 4p is going to be 0. Okay, so D sub shall have 5 orbitals, but electrons are how many? Only 3. Okay, now 4s 0 and 4p is always 0. Okay, so here how many? 6 coordination number. Coordination number is how much? 6. So 1, 2, 3, 4, 5, 6. So hybridization is going to be what? D2 Sp3. What it is going to be? D2 Sp3. Okay. So in the D2 Sp3 hybridization, what should be the square bipyramidal? Square bipyramidal is also called as octahedron. Okay, now there is some special name added to it. What is that special name? Here with the 4s we are using 3D. Okay, that's why this is also called as inner octahedron. Okay, 4s before that 3D we are using. Okay, otherwise it is also called as low spin octahedron. Okay, low spin octahedron, because 4 is high and 3 is low spin. Okay, otherwise spin free, what it is called as spin free octahedron. Okay, in the octahedron itself, if 4s is combined with 3D, what other chances are there? When you will do it, we are going to cover it just now. Okay, so 3D 3, 4s 0, 4p. So inner or low spin or spin free octahedron. Okay, and what is the magnetic nature? It is paramagnetic. Which magnetic? Paramagnetic. Okay, are you ready for the next example of the coordination number 6? Okay, good. Okay, next here we are with the next example of FeCN6 3 minus. Okay, so Fe atomic number is 2 6. Okay, so Fe electronic configuration is going to be helium, neon, argon. 4s2 3d6. Okay, and 4p is going to be 0. Okay, okay, it is AR 3d6 4s2 4p 0. Okay, now 3d6 1 2 3 4 5 6 4s2. Okay, and 4p 0. But what we have here is oxidation number. If you find out the oxidation number, it is going to be plus 3. What is going to be the oxidation number? It is going to be plus 3. So for that, I will eliminate 2 electron from here and 1 electron from here. Okay, so argon and 3d6 is going to be formed as 3d5. 1 electron from here, it is eliminated. 4 is 0. 4p is 0. But the problem is that we require 6 empty orbital, okay, for that, and Cn minus is a strong field ligand, okay. Therefore, pairing done against Hund's rule, okay. Pairing done against Hund's rule. Is it audible to you all? Okay, against Hund's rule. Then what happens? This electron will come here. This electron will come here. Okay. So there is no change in 3d5. It is going to be 3d5 only. Only thing is it is going to provide you. It is going to provide you with one unpaired electron. Okay. So 4s 0 and 4p 0. How many we should count? We should count 6 empty orbital. Okay. So 1, 2, 3, 4, 5, 6. So hybridization is going to be again D2sp3. What is the hybridization? D2sp3. But what is the difference between before and this one? That was done when electrons are already empty orbitals are already available, but here we are making because a strong field ligand is there, pairing is done, so empty orbitals are provided afterwards. Okay, so if this is not there, then the coordination number 6 only. I am going to take another example. Okay, so if this is not there, in this place I am going to write FeH2O6, but it is 3 plus. Third example I am making. So in this only I am making the changes. So because of this, oxidation number is still +3 only, and atomic number 26 up to here same, up to here same. Okay, but for H2O, this pairing will not take place. What will not take place? Pairing will not take place. Okay, but we require 6 empty orbital. For that, what we will do, I will write it here again. AR 3D5, AR3D5, 4S0 as it is, 4P0 as it is, then we will use 4D orbital. Okay, because we are not getting any type of help from the 3D. We are not getting any type of help from the 3D. Okay, so because of that, what happens? So 4s 1, 2, 3, 4, 5, 6. 6 is coordination number. Okay. So hybridization is going to be sp3d2. Okay. It is called as what? Octahedron. Or it is called as octahedron, otherwise square bipyramidal. Okay. But I told you there are certain new names are also added. So that it was inner octahedron, now it is going to be outer octahedron. Okay, otherwise that was low spin octahedron, now it is going to be high spin octahedron. Okay, and now that was what else? High spin and spin paired. Okay, what it is called as spin free octahedron, because electrons are unpaired here. Okay, so I think in that I told spin free or spin paired. That was spin paired, now it is spin free. Remember this is spin free. Okay, so all the examples of the coordination number are over. Now I will give you a summary and very important information required for direct attempting. Okay. Okay, like this, I am going to give you the complete summary. Okay, what is the coordination number, and what is the structure, what is the examples. Okay, right from the beginning to end of this, I'm going to give you examples. Okay. Okay, these are the some examples where coordination number 2, sp hybridization linear. This example I have covered. This you can practice. KAgCN2 square bracket close. Then this I have not covered. You can practice it definitely. I am having confidence on you people that you can cover it nicely. Okay, so sp2 triangular planar khgi3, and if coordination number is 4, hybridization is sp3, then because coordination number 2 examples are there, tetrahedral shape, and FeCl4 2 minus. Okay, NaCO4 already discussed, NaCl4 already discussed. Like this, you can give a try. Okay, and ZnCl4. Some examples are there. You can practice with them. Okay, next coming to 4, DsP2 hybridization square planar, and example this already covered. For your practice, I have given this PTNS3 4 2 plus. Very exceptional case. CuNH3 4 2 positive. You try, you will get some other answer, but the hybridization and shape, the electron from the S subshell is transferred to the D subshell. Okay, so that is the specialty case. S not D subshell. From the D subshell, it will be transferred to the P subshell. Instead of sp3, it is dsp2. Okay, very important thing. I think you will do it and practice it, and I'm going to give you some more example of 5 coordination number and coordination number 6. Okay. Okay, like in the previous board, I have explained extra. What is the extra? Coordination number 3, sp2 hybridization. Okay, I think you have paused it and made a note. If not made, just slide it back and take a screenshot or pause it there and note it. Okay, so sp3d hybridization, this is not covered that side. Okay, so that you can cover it and you can write it. Very easy questions. So square bipyramidal SbF5 2 minus. Example is SbF5 2 minus. Okay, and this already covered 5 DsP3 hybridization triangular bipyramidal. This I have explained. This you can give a try. 6 sp3d2 octahedral. This I have explained. This you can give a try. This octahedral name also I told you, outer octahedron, high spin octahedron, spin free octahedron. Okay, this is spin paired octahedron, low spin octahedron, inner octahedron. Okay, D to sp3, and in this example I have covered these two example. You can do it. Okay. So all the best. Now I think all of you are perfect in hybridization of complexes, structure of complexes, magnetic nature of complexes. Okay. Have a bright future. Keep visiting Chem and share it to your friends. Give it a like and write a good comments. Waiting for your good comments. Bye bye.